Thank you all to be back to the hands-on session. In this session, we will just let me share the next slide. We will go to some deep learning theoretical background. We still need to talk about the layers of deep learning and how it learns. Let's go through the activation function and also with the propagation algorithm. That's the purpose of this, is to give very strong understand how deep learning works. So the next is going to be developing a deep learning network step by step. We're going to do this with 4 examples. And after I will show you the resources you have available for deep learning. So 1 minute. Okay, so deep learning layers, activation functions, propagation, and algorithm. And also I will show you a very good example about Boolean functions representation. So you have a few neurons and see how it works, how activation function works with real numbers. This is very good. When you take lectures about deep learning, basic, you face this kind of material. So let's go back to the neuron. Yes, we have I believe you understood the inputs and outputs of a neuron. Okay, one more thing. Before jumping to the presentation, thank you for answering the poll about if you install Matlab, if you have installed Matlab or not. So a majority of you have installed Matlab. Probably you're going to have this 2020B version. I want you to do one thing. And also you have the material as 4 folders. I want you to do one thing before, because it may take a few minutes to download. So please go to open Matlab and go to add-ons just by clicking here. So click here, add-ons. I'm gonna open this. And here search for AlexNet, because we need to download the pre-trained model. After this, you will see this deep learning toolbox model for AlexNet network. So I will give you some time to get there. Open Matlab, home. You're going to find in environment add-ons, add-on explorer, AlexNet. Results you need to be connected to internet to do that. You will see deep learning toolbox model for AlexNet network. Click there. And this is the model. So you will see a button to install. I see manage because I already installed it. So you see install, and you're gonna give you the option of download only or install. Click install all. Okay. And after this, it's gonna open a small window, and it's gonna say gonna show the progress of the downloading and installation. Okay. So keep that that window running, and I will go back to the slides. And when we finish this part, you're gonna have the AlexNet installed. Okay. Thank you. So let me go back to the slides. So here we're going to talk about activation functions and how the knowledge stays on the weights, how it learns, how the weights are adjusted to have the values. So deep learning layers combines multiple nonlinear processing layers using simple elements operating in parallel and inspired by this brain, yeah, the biological nervous systems. It consists in an input layer. You have here on the right, on the left, sorry. Several hidden layers can be hidden. Here you have two, but you can have several of them. And then an output layer. You have one single output here, but you can have more than one output. This is what we see about a hidden layer. The hidden layer can have more layers. Like we usually have a convolution layer, and our ReLU is going to be activation layer, and a pooling. We're going to explain how it works. What is this? Okay. So a famous network is the convolutional neural networks. It's called CNN or ConvNet. So it's one of the most popular algorithms for deep learning with images and videos. I believe you had seen this before, and I will explain you what is a convolution. So like other networks, CNN is composed for input layer, an output layer, and many hidden layers. So the AlexNet use the CNN. We're gonna use CNN as well for the training part, for the hands-on session. A convolution puts the input images through a set of convolutional filters. So each of which activates certain features of the image. So here you see on the matrix 6 by 6 and 3. 3 is the number of channels. It also is number of dimensions, we can say. When you have a colored picture, you know this picture. If you bring it to Matlab, you'll be able to see that it's a matrix of 3 dimensions. It's the R for the red part, GB, RGB. So red, green, and blue. This will give you values for the colors. This means like each cell here, each pixel can vary from 0 to 255. And this is for each one. So if you multiply 255, 56, because the number of values, times 3 cube of this number, you're gonna have the 16 million colors that's possible. Okay. So this is the RGB. And this is our filters. These filters are called also the convolutional kernel size. What's going to be learned by the network to extract the features. And you have a result. This is the equation. Let me bring annotation here to my slide. So this is the equation of the N out. N out is this, is the output of the. Let me try to draw here and out. Here we have N in. N in is this value. It's one, usually it's square value, so you have the N in. And here is the K is the number of convolutional kernel size. Kernel size is this filter, so the size is this value, is the K. And S is convolution stride. In this case, we don't have it, so it's 1 actually. So the stride is the stride actually is going to be the step, because this filter will be here, and it's going to jump again to the second one, 1 by 1, and it's going to jump to the second one, 1 by 1. So the stride is 1, S equal to 1. And the P is the convolution padding size. Sometimes your image, you can add a padding. A padding is some zeros on the border. So just to, the 0 values is just to make the image a little bigger. Okay. In this counting, we will not have it here, but the next example, you're gonna see this padding. So here we have the N out. It's going to be N in is equal to 6. We don't have P is 0. So we don't have this, minus 3. The Let's try this one. So we have here 3 plus 1. We have 4. So this is the result of the convolution with a filter with this size. Let me clean this. So for better understanding, see this GIF. So here is exactly what I'm telling you. We have 3 filters, each one for each 3 kernels. Yeah, they have the values and they have the image values. So it's going convolution. Convolution is this action of the filter to go through. It's a small matrix doing this linear algebra on a bigger matrix. You see, you are seeing this value, and you will have a result. But what counts for us as a neuron is going to be the sum of the results plus 1. So this result is going to be the output of the same value on the convolution result. It's going to be a matrix as well. Okay, so this is a convolution. This is what happened within the training and within the execution of the deep neural network when you use convolutional neural networks. If you have more questions, I encourage you to see the documentation in Matlab, and it's going to be very well explained. Another network is the max and average pooling, sometimes called max pooling or average pooling. See, this pooling is the output by performing nonlinear downsampling. So it helps to reduce the number of parameters that the network needs to learn. So you see max pooling returns the maximum value of the portion of the image covered by the kernel. And on the other hand, the average pooling returns the average of the values from the portion of the image. So you see here in the first square, the max value is 20. So its max pooling returns 20. Here is 30, 30. Here is 112, 112. But in the other case here, what's going to happen in the average pooling is going to sum all these values. These values are pixels, okay? Every cell you see here in this matrix is a pixel. And it's going to give the average pooling. So this max pooling is good for noise suppressant. So we're going to discard some noisy activations altogether and perform denoising of the image. Okay, so that's the good part. You will see in every network you have a max pooling layer. The fully connected layer connects every neuron in a layer to every other neuron on another layer. So it is as simple as the same as the traditional multi-layer perceptron, but in this case you don't have the activation function. So the purpose of a fully connected layer usually goes to the end of the neuron of the network. It gives you a non-linear activation. Let me make it clear. So it's fully connected layer is a cheap way of learning non-linear combinations of the high-level features as presented in the output of the convolutional layer. Lstm. Lstm is known as, it's a type of recurrent network, called also RNN, and that can learn long-term dependencies between time steps of the sequence data. So it can make recurring information such as present within time series, and it can outperform other types of the neural network, so which doesn't use the temporal information. So here, what you can see, what time is it? So this is a sequence of text, and text is sequence data. It's like signal. The what information is propagating through the next output. So every word is the next output. So you see the color gives you the time, knows that what is there. Even the last derivation signed, you see the what is there. So it makes sense. When you use it, yeah, you are using this already when you're typing on your phone. You know they have this word prediction. So when you write one word, give you a prediction with the next word. Actually, what is behind this is a long short-term memory network. Oh, it can be one. Okay, do have a lot other algorithm, but usually nowadays this one is very strong and probably is embedded on your device to do this word prediction. Another application is for time series. Yes, you have sequence data. So the purpose is you have a window to see what happens in the past to predict the next point. So here, for example, we see in the window, this is a time, you see. To predict the double T plus 1, you need to learn what is behind that, like what is the WT in this window. So it's very good use for with this window sliding to predict, to forecast some time series information. You want to forecast I don't know, this doesn't apply that well for trading, for the stock market, because it's not something that doesn't have a lot of human intervention within that. Yeah, it's not depending on other factors. But you have some sensors, and these sensors give you an output of a control system. And about this, you can use this sensor information, Lstm, to give you this information. So some of you probably are downloading the AlexNet, okay? So go ahead. If you have any questions, please go to the chat. We have Hassan to help you there. Thank you. So you're seeing the network in a different way. Remember, we have input layer on the left, hidden layers in the middle, and output layer to the right. Now we are seeing from bottom to the top. So the input layer is there. This is how Lstm works. You have the hidden layers and the output. So the hidden layers are communicating to each other. So this is the time connection between this network. So this has a lot of very good applications. All of them are connected. And at some point, for example, the next 200 hidden layers are connected to the others. Okay, you can choose this number. Now let's go to learn activation functions. Remember this perceptron, so this have the activation function. The activation function can be tangent hyperbolic, sigmoid, linear, or ReLU. Let me explain each one of them. So a linear function to activation function is not the best one because it's constant, so it's not possible to use in best propagation. And the derivative of this function is just a constant. You have u, you're going to have exactly, it's going to be a constant value proportional to this. The other one, binary step function, is a threshold-based activation function. If the input value is above or below a certain threshold, the network is activated and sends exactly the same signal to the next layer. The problem with this step function is that it doesn't allow multi-value outputs. For example, it cannot support classifying the inputs into several categories. Just give you is above 1, give you 1. Below, you're gonna give you 0. So one of the most used one is a sigmoid function. Sigmoid function, also known as logistic function, is a mathematical function having a characteristic of S shape. A common example of sigmoid function is this logistic, and it's shown here in the figure. This 0 to 1, you have this curve. So a good advantage of this function is the smooth gradient. So it prevents some jumps into output values. You see, if you have, so this curve goes to infinite. So if you have the infinity, if you go from more than 4, it's gonna be close to 1. You have less than minus 4, you're gonna have you're gonna reach 0. So the output values between 0 and 1 can be normalized. It's good for each neuron to learn 0 to 1, normalizing values, and give you clear predictions. So if x above 2 or below minus 2 tends to bring the y value of the prediction to the edge of the curve. Okay. And the disadvantage is this. For very high or very low values of x, there is almost no change. Okay. And can cause some vanishing gradient problem. Okay. This is a network that will not learn more if these values reach the top. Okay. Our outputs are not zero centers, so you don't have zero values there. And it's actually computationally expensive. Okay, so it takes more time to be processed. The rectified linear activation function, or ReLU for short, is linear function that will output the input directly from if it's positive, otherwise if it's gonna output 0. So you have the value if it's positive, otherwise it's gonna be 0. So a good advantage is computational efficient. So the network allows it's very fast to converge. But one thing here, let me show you. Like you see, it looks like a linear function, but it's not. It's in fact a non-linear function, allowing you to describe these complex relationships in data. You see, it's not give you a, because below 0 is another value, after more than 0 is another value. Okay. So also you have some activation functions, some variations of this ReLU. Okay, you can where you can find very good documentation is in the Wikipedia. Go to Wikipedia, you're gonna find this comparison of activation functions. You have not only this number of functions, you have many of them. And this is important to know because you need to choose this one for training your model. Okay, so go there, you have the address here, and you can learn more about activation functions. So let's go to backpropagation, our last theory topic. So backpropagation is a supervised learning algorithm for training artificial neural networks. And backpropagation algorithms looks for the minimum value of the error function in the weight vector space. So using this technique called gradient descent, I will explain. The weight that minimizes the error function is considered to be a solution for the learning problem, sorry. While designing the neural network, in the beginning, we initialize weights with some random values or any variable for that fact. So we'll see more about how is the gradient descent and how the weights are updated according to the error or also called learning rate. If you started a course about machine learning, probably you have seen this picture, this graph before. This is the gradient descent from the book of machine learning. Is Tom Mitchell. So gradient descent is a first order interactive optimization algorithm for finding the local minimum of a differential function. So to find the local minimum of a function using gradient descent, will take steps proportional to the negative of the gradient. So here's you have some, so here you have one weight 0 and another weight. So the purpose of this is to use these two values and reach the minimum in this case, okay? So it's cool, when you are training your model, it goes through here to here to try to find the minimum of this function. And it uses the This is the use the learning rate. The learning rate is this value here. Okay, also here. And this is the next slide. So let me show you the learning rate. So the amount of the weights are updated during a training is referred to the step size of the learning rate. The learning rate is a configurable hyperparameter used in the training of neural networks, and it has a small positive value. So usually this learning rate is very small, around 0.01. Okay, can be less than this, can be more than this, depends. And in the left case, you see the algorithm successfully finding the local minimum of this function, but you cannot be sure this is the minimum. Yeah, this is the global minimum because the function continues. But in the local minimum, it finds. In the other case, in the right image, you see the step coefficients is too high, of the learning rate is too high. So the algorithm bounces around the local value without finding the values there. So you have two things here. A low learning rate, okay, will reach a local minimum, but maybe it will not reach a global minimum. And the divergence happens when this learning rate is too big, and it bounces back to between the local value, but doesn't give you this local minimum. Okay, but also this one can reach better result for the global minimum. So you need to make the experiments with changing the learning rate to see different results. This is a hyperparameter changing. So this is a gradient descent of to illustrate, yeah, is a traditional example of linear regression. So this is, so you adjust the best fit line to some data. Suppose we have this data points in X and Y, and so what is reaching the minimum is to have the relation of this value. Okay, you find these M and B values. Okay, now let's go to backpropagation. Now we understood what is learning rate and what's gradient descent. To do so, I will show some slides for the training of a multi-layer neural network using this backpropagation algorithm from this 3 layers neural network. So we have 2 inputs and an output, and you have one layer. Okay, so let me show you. So this is the way it propagates. You have the input, you have the weights. The weights are rows, you see. So this weight is going to be within the function of activation. So the function is going to be the sum of the weights and the inputs. In the next step, we'll do this for the other one. This is happening like thousands of times in your computer when you're training a deep neural network, DNN, I can say, a deep neural network. So you have for the next one, you have another layer. So now you get the output or the first neuron to use as input for the next. You have the weights there. Okay, well, this is very important. One layer is going to give you one output, and you put this output in the next layer. Here also you have Y1, Y2, and Y3 to predict Y5. And when you reach the end of this, you will compare that's when you have supervised data. You will compare the actual output, and you will see if you reach that point. If you didn't reach the output, desired output, you will be back, and you're going to propagate the error. Here you can calculate this error. You propagate the error to the weights. And now you need to update the weight. Now you update the weight. You have the error. You have the learning rate. So this small thing is you have the differential equation of the gradient descent. Okay. So this will give all the weights and come back. So this, well, let's come back here. So this is called in the beginning, the forward propagation. And when you're back, it's called back propagation. Okay, this happens many times. Let me just clean here. So see this gift. This gift shows you exactly step by step how your computer calculates the weights and updates them after. Calculate the error, use the error to update the weights. Okay, so we did a forward propagation and a back propagation. And okay, now we learned how it learns, the deep learning. Let's see some you know probably the logic end is a Boolean representation. So here you have x1 and x2 that can be 0 and 1. You have the logic end. So let's do it. Let's make a network to do this function. So we give value to the input. So the input can, this is a bias, okay? Remember I have a bias. And this is the input 1, input 2. And you have weights, plus 20, plus 20, minus 30 are the weights. And here's the summation of everything. And you go through the function. So here you have the bias, minus 30, the weight minus plus 20, the input x1, x2 you have it here, and 20 you have here. Is that you have here. So you sum this, it's going to give you a value. And you have this, you pass through the sigmoid function, this activation function. So you are reaching, in this case, for example, x1 is 0, 0, we have g minus 20, minus 30, sorry. So this is very quite far here. So it's close to 0. Minus 10 also is very far 0, and minus 10 as well. And 10, you see, it's close to 1. 10 is around here, so give you a 1 value of the output. So this is exactly an AND logic gate, give you this result. Let me see now other types of Boolean representations so you understand. So we have for the AND, we have for the OR, we have for the NOT and not x1 or not x2. But this is what usually you have. If you have an exam, you need to write down exactly calculate it. You're gonna write on this values. So how you combine all of this to make this exclusive OR gate? Exclusive OR, you see that you have in the first quadrant you have a positive, and in the third quadrant. So it's quite difficult to separate this, you know? So the power of neural networks is you can do it. So we have exactly the x1, the x2, and you're gonna use the AND and the NOT for the first, for the intermediate values. So here you have in 1, in 2, and after you're gonna use the output of this for the next. So you have 1 or 3. So here you can see a table. The exclusive give you, the O exclusive give you 1 if they are the same. Okay, so 0 and 0, first one gives you 0, 1, and give you 1 because it's 30. 30 is very all the way to the right on the sigmoid function. This is a sigmoid one. And 1 and 1 give you 30 as well if you follow this function. If you multiply exactly these values of the inputs here, it's going to give you this. Okay, so this is a very quick one. Now we're going to jump into the hands-on session. So we're gonna see the classification of handwritten digits and transfer learning from AlexNet and detecting cars with YOLO V2 and classifying air compressor sounds. The last two demos will be already written. So the first two demos we will write in every line of code. It's not a lot of them, and you have some good live script to make it. So we already went through the workflow. So let's create a simple neural network for classification. So this is if you write a number, you will send the image of this number you wrote down and written writing to the model, and it's going to give you the number it is. It looks like simple, right? But this was, if you visit the website of Yann LeCun, Yann LeCun developed this in 1998. This is actually one of the I believe it's the first convolutional neural network, and it was developed to predict to classify the numbers of a check. So you have a check. When you put the check on the ATM, in some ATMs, it automatically is going to read the value is there. So the machine say this check has this $1,500. So exactly it's going to tell you that, if without you to write it down. So to do this, we're going to load the data, export the data, define network architecture, specify training options, training network, and predict the labels, okay, and see the accuracy. This is called LNet 5. This is very robust neural network. You see here in the image how it works. Here you have on the right, where is my mouse here? So here you are pressing every number, and here's the answer. So sometimes it doesn't have an answer, but sometimes it gives you 1, 2, 3. And this is a network. So you have input image, you have a feature maps. Feature maps are the convolution of this intermediate values, and have some S2 is a subsampling of the max pooling. You have another convolution layers, so you're reducing the size of the image, and also you have another softmax to have the last values. You have another convolution layer. You have the fully connected layer, and also you have in the end the output. So what is it doing? You see here this convolution. You have 1, 2, 3, 4, 5, 6. So here is the same as this. So the system learn the architecture after training. This is now execution. Learns for every convolution here. You have 6. Learns to extract different features of the image. You see, some of them have detect borders, some of them detect what is inside the numbers, some of them detect white in the background. So this is the second convolution, but it's called the C3 layer, and this is the 5 convolution. So you see the image that is started to be 32, 32 is reducing to 28, 28, going to 10 by 10, and now is just a vector of 120. Okay. So this is the image. So they have the output and here. So this model also brings was trained with some images they are distorted. So it's robust to noise, and also to multiple change recognition, multiple character recognition, because if you just distort the numbers, you can see here they distort and still have the 384 output. So this is very important to have a robust, have noise on the image, and you have also distortion. So let me see the next. Okay, so let's jump to Matlab. Okay, so I belive you have downloaded the AlexNet. If you didn't download, go there to add-ons, home, add-ons, look for AlexNet. AlexNet, find this deep learning toolbox, 2, 3, 5th one. Yes, and download it. So now we have, I believe you have these files. If you download the files, go to the, let's start with the train a basic convolutional neural network. You open this. First of all, please go to your folder, because to avoid having problem of path, click on the folder you have everything, add path, selected folders and subfolders. This is very important. So all the folders and subfolders will be on the path of Matlab. You do this. After this, you just enter the next convolution layer. The train a basic convolutional neural network. And here you find the one with all the code. You will find one written blank. Let's write on the blank, because we're going to write code by code, line by line of code. Here, if you're not familiar with Matlab, this is called a light script. So I believe you have faced some of the notebook in other open source software, and this is when you bring titles, text. You can include some images, links, okay, for documentation. Okay, this is very good for writing your experiment, and if you want to generate a PDF of this or a Word document, you can do this. Okay, I will save. You can save as PDF, as Word, HTML, or LaTeX. If you're writing a paper, it's very good. So let's start to bring the explore the data. So, to load the data, you're gonna use the function image store. So let's give the name of MNTS, and I'm gonna use the image function. So you see, when you type in this live script, it's gonna give you the function. So you see, image, if I write that the stores is trying to complete. If you type tab now, it's going to complete the function. Okay, so I encourage you to use this. So now, if you open, it's going to tell me where is the location of the file. So also it gives you the location. So the location is within this folder, the digit image set. You can just write this and the whole folder. We're going to bring the whole folder. So let's investigate what we have inside. We need to, before this, we need to set another thing. So include subfolders. If you go, we are with this image, you go to include, press enter, arrow down, you can see all the parameters you can set. Include folders. Gonna give you true, yes, reflects true. You put a comma again. You have a label source. So from where is coming the label of the data? The label is coming from the folder names. So if you close this, and don't forget the semicolon. Okay. What's it gonna be? We're going with this function. If you have any question about the function, click with the right over it, help on image store function. Image store dataset, you have all the documentation here, okay? Location, what you need to provide, and other syntax and other values. If you want a bigger one, you can click here. It's gonna open this documentation. And you can see some examples of how to use it. Again, we're going to this function because if you enter the digit data set, you're gonna find the functions the folders 0 to 9. And if you enter 0, you're going to see images there. If for each one, you have 1,000 images. You see? No, sorry. 10,000 images. The images are very small. You see here, for example, click. They have zeros, but with different distorted. You see, it's not. You see the image down here. This is different. So navigate here to the current folder. So we are doing with this function. We are not bringing the data to Matlab. We are just pointing where is the data. Okay, to run this, you can use run section. You see this small line dividing the sections. This is what you can divide your sections. For example, if you use section break, you can write more code here. Okay. We're not using this break in this one. So when you run the section, is going to run only what is inside this, between these two breaks. This case is this here. So let's run it. So you run it, it's going to give you a value here of image data store. If you go inside this, it's going to give you what is inside this folder. So you have the folders, the folder where I'm having this, the files, so many files we're going to have there. It's saying 10,000 files, and the labels. So let me see all of this, 10,000 images. Now let's display some of the data. So I'm gonna make a very big fast code here. Just do the same I'm doing here. So we're gonna get some random images with this function random term, just to give random images. We have 10,000. Okay. Let's get 20 of them, and let's make a for loop just to bring these images and plot there. So for loop is going to be equal to 1 to 20. 2 dots is 20. You press enter, it's going to give you the end already there. I'm going to subplot 4 by 5, it's going to be 20. So we need to make a subplot. 4 images by 5. So it's going to be 20. So it's going to put the I inside it. Now let's use the image show functions. Image show like this. When we open, we need to add the location of the data set. IMDS we call it, dot files. And inside this, we're going to random take an image. Perm is our value over there. Take value 1. And that's it. So if you run this, everything is all right. It's gonna plot random images from the data set. So I have 2, 6, 4. We have 4 lines here by 5 columns here. Plot. If you want to explore more this plot, okay, we'll make it outside. You can zoom it inside each one. You see the images are small digits, yeah? Very small image. Okay, I will keep this. If you're not following this, you have another code here. train a basic convolution, you have this answer there, okay? Don't worry, you have all the codes there and all the data set. So next one, let's calculate the number of images in each category. So to do so, you need to count the label. So let's make a variable called label count. It's gonna be make label caps the count. It's gonna be equal to count. There's a function count each label. Now here you need to give just the number of the IMDS, the data source, image data store. Okay. Data store is here. Okay. We do this, if you run this section, it's going to tell you, okay, you have 1,000 images for each label. Right. The label is coming from the name of the folder. So this, if you see, the image doesn't have name. So you can provide the name on the folder. This is very nice. So the next one is next step, we're going to specify. Sorry, I have a question. Give me 1 second. Okay, so if you're facing an error, exists number array of elements, you need to make sure if you're following the things, okay? To be able to run this, you need to be with the folder here, okay? It's just seeing, this is seeing what you have here, so it needs to be there. If you have problems, go here. You have some more annotations here. Copy this and put it there, okay? Here you have some of the action we're doing. So we're working on the blank one to make you type the function. You see, like, one function can bring a lot of functionalities. So now let's specify the size of the image in the input layer. So the network, for the network. So in the size of the first image in the digit data, each image is, we know, is 28 in 1 dimension. We can just use functions to do this. We don't need to write the size. For example, the image on the, let's read an image. Read image. The IMDS, that's one, the first one. And let's see the size of this image. The function size gonna give you the 2 dimensions of the function. So now the answer is 28 by 28. Okay. So I specify the training and validation sets. This is very important. Remember when you say, okay, you need to separate some of the data for the training set. So we have in this case, we're going to separate 75% of the data for training and 25% of the data for validation. Validation of testing, means testing in this case. So let's write the number of. It's very important to follow the steps so you get familiar with Matlab. Train file, make the same. So num-train files is gonna be 75% is 750. So now let's split it. You open this. EMDS train. Let's name this our first input. Output, sorry. It's going to be the second one, the validation. Okay. So so now let's use the function split each label. Here's the function. So what's going to happen? We're going to provide the data store, is the data, the location in the folder of the data, the number of files. So if you just type num, you're going to provide you the first enter. And we're going to use the random function, random option. You can write that random, or you can just type tab. Okay. So let's run this. So we're going to split our data set using 75 for training. Using in these first values that if you click there, help, it's very easy to see. The one is going to be the training, the second is going to be the validation, and or you just give a name. You split in this the data stores, and the P is going to be the P can be either a number between 0 and 1 also. So you can point 0.75. It's also possible. Okay. So let's run this. Now we have a training label here. Now let's define the architecture. This is the funny part. Okay, how I define my layers? In Matlab, you can write anything, but let's use layers. And that's the way you do. So you open like this. And you can write, when you are between this, you can write in any form. So the first layer, we're trying to build this. Okay, this network. So we have the input image, we have this convolution, sampling, convolution, sampling, convolution, full connection, and output. So we're going to build this. So the first one is going to be the input. Sorry, it's called image input. Image input layer, sorry. And you provide for this the 28 by 28 by 1. This is the size. After you provide, let's make the convolution. We're going to make a small change here. The convolution is going to have, instead of 6, the original LANet 5, 6 layers of convolution. We're going to use 8, okay, because this is better results. With time, we try different approaches, and also we put some normalization layer in the middle and brings better results. So let's use the convolution function. It's called convolution and 2D layer. Okay. So there, the first value is going to provide is the filter size. Our filter size is going to be 3 by 3. Remember when I showed the 3 by 3 filter? So this is the number. And how many number of filters? We're going to have 8. So give me a minute. And now it's asking you for, it's going to ask me for padding or something else. So we're going to add some, padding is going to be the same. Same means that we will not be padding. Okay. And now we're going to add a batch layer. This batch is to help you on training. Batch normalization layer. Just write this and ReLU layer. ReLU layer. Okay, we built the first convolution with a normalization layer and a ReLU layer. This ReLU layer is going to be, remember, is going to be the activation function. So now we need to add the max pooling. max pooling is going to get the maximum value of a window and provide the values. So max pooling. So yes, we have it 2D. And now you need to provide the size of this window. So the size is going to be 2. And means that you're going to have a 2 by 2 matrix. And every 4 values of the matrix, you're going to choose 1. So you're going to choose the highest one and make 1. For this, we use a stride. Means a stride is the step it's going to take. It's going to be 2 because we're going to want to take the value of 2, and after the size is 2, we're going to jump to another new values. Also, let's now to make another convolution. Okay, so to be faster, we're going to make same convolutions with this. Let's copy this. Copy. Paste. So now the other one, but now instead of 8, we're going to have 16 values. The background layer continues the same, and the max pooling will continue the same. Okay, and we have another convolution layer after this. We have copy. You can press Ctrl+C, Ctrl+V. Okay. So now our convolution layer is going to be 32. So we're going to 8 for the first one, 16 for the second convolution, and 32 for the next, because our image is becoming smaller. And layer, and now we finally add the fully connected layer. Fully connected layer is going to be the same as the output. 10. We're going to have 0 to 9, so it's going to be 10 output. We're going to softmax layer. This is to get the maximum value of this layer in a classification layer. Sorry, it's classification layer, yes. So this is the network, okay? We finished the network. We finished not exactly this. Instead of 6, we have 8, up to have 16 and 32 of this, and we have the output. So if you run this section, the output is going to be a layers, a file. You see, if you click twice in your workspace, you hit layers, and we're going to see the values of each layer. You have many different parameters to set. We set only a few of them. Okay, some of them are automatic. If you want to know what is exactly behind this, go to Convolution Neural Network, Help, and let's open this bigger one. And let's understand that to convolution layer applies the sliding convolutional, and what is a layer, what are the properties of convolution, and give you some example. Here, for example, more about convolution layer. Here is exactly what I want you to get. You have questions in Matlab. Okay, I didn't learn that. No, it's not a big problem. Okay, you can handle. You can go to the documentation. There is some theory over there, so you can just see how is a convolution. It's showing here. I have very good summarize of how it is. And if you still have questions, you can go through the references. Here give you everything Matlab have references. It's just we are applying the function of a paper or a book. And the lecun you have here, lecun. So you have these publications in 1998. Okay, go there, please. learn exactly what you're doing every step to fix it. And now here, as a result, we see the layers we have. We're almost there. Here, if you want to learn about the layers, we have some input image, convolution layers, batch normalization layer, and ReLU, max pooling, fully connected. I have a small summarize of what it means. Okay. So for specific training options, remember I told you about the options. This is where we're gonna set the hardware as well and all the options. The function is train. Training options. Yes, here. So you give like. So now we're gonna use as a. Just give me 1 minute for getting water here. We are gonna use the gradient descent. Okay, the solver name. If you want to know more, I encourage you to go to the documentation. We don't have time to cover all of them. We have CAD and we have more than this. So you just press a comma and it's going to provide you. So go to initial learning rate. Just write I, initial learning rate. We're going to start with 0.01 learning rate. Okay. We can do less than this, more than this, no problem. Now, number of epochs, max epochs. So what means a max epochs? Epochs is how many times all the data will go through the network. So we have 10,000, but we are using training of we're using 7,500 images. So one epoch means all these 7,500 will go through the model. This is one epoch. We're going to have 4 times for this. So we want 4 times all our data to go through the network. You can decrease this, you can increase, depends of what you want to do. So we're going to shuffle the data for every, there is a shuffle function. Sorry. Shuffle. So this shuffle we're going to do for every epoch. So it's going to mix all the data again. Doesn't in shuffle like means for every iteration is going to mix the data. This is very important to bring the robustness to the training. The next is going to be the validation data. So remember we provide some validation data there. So we have the validation data here, yes. And the validation data is exactly what we have, the indices. And the next is gonna be, so it's becoming big, right? So if you press 3 dots, you can jump for the next, okay? Let's do this. So here, let's press 3 dots in Matlab. We can jump for the next, okay? Just to be in the same view. So now we have a validation frequency set. Yes, it's gonna be 30. And now the variables. So variables means that if you want to plot what you are doing there, but let's keep the variables. Plot. Let's make this training progress to see what is the progress. And another one we can set is remember the hardware. So we have a function here to execution environment. Auto is going to run, if I put auto, is going to run on my GPU because I have GPU in this machine. But also you can set a CPU, GPU. If you don't know if you have a GPU, use auto because it's gonna train on the CPU otherwise. Okay. You have a multi GPUs in your machine, or multi GPUs you can use, more than one GPU, or parallel. Depends if you want to connect to a data source. Let's go keep auto. And these are all my options. So you see, it's not that easy to write all the options, but it's important. So after finish, let's run this section. Now let's train the algorithm. So we're gonna write the name of my network is gonna be net. And I use the function train network. Here I need to provide the data. It's the image train data. And the layers. And the options. Okay. So now what's going to happen? I would, this training is in my GPU is very fast. I don't know how long it's going to take in your computer, but let's see. When you run this, it's going to start the training. So your computer starts to make noise, depending on how old is your machine. And you see, it's going, because it's going to, I recommend to be on the, your computer to be plugged on the outlet, because it demands a lot of current. Okay, so let's run it. It's going to open because it's going to open this neural plotting. So here you see it's using my GPU. It tells me every epoch is going. You see, is starting to have iterations. You have many iterations per epoch, and it's getting from 10% accuracy in the first run. We finished the first epoch with 90% accuracy. Now the second epoch finished with 95%. Third epoch 98, around 98, and the fourth epoch, let's see. Oh, it finished with 99.04 accuracy. You see, it's almost 100%. It's very good. It took only 40 seconds. And here you can see the values of how it was. 10% all turns very fast. And when the first time he saw all the data, got 90%. But it takes time for this very slope here to take the 100%, to climb 99% more. You feel something like that when you're doing deep learning. Okay, you see in the first 2-3 epochs, the model will learn, will go to 80%, 90%. And to get from 90% to 100% takes another 100 epochs. This is a trade-off, you know, because it needs to learn very small features. And here you see the loss function. So you're getting a loss of 2.5 and going down. The purpose of the training. The opposite is the loss. So we have to reduce the loss. If you go, let me see. So it was training in a single GPU. My learning rate was constant. I have a 0.01 here. It's going to be 30 iterations for the validation. And yes, so I have 4 epochs. In these 4 epochs, I have 32 iterations in total. So let me go minimize this. So here also we have some of the variables of the training. Training on a single GPU and give me what happened every epoch in some iterations. So in the first epoch until the 90 iterations, 19 seconds, we already got very good result. You see it got 100%, they say here. But this is on the training data set. On the validation accuracy, validation data, it got 99%. What is validation? So the model runs And after finishing a couple of iterations, it's gonna run on the validation. Validation is the data that was not trained for, or it's different data, or it's the testing data. Here in the, you have the error here, mini batch, error, and the learning rate. You can change the learning rate. Now let's test our data set, our network. To do that, we're gonna run on the data that was validated. We're gonna use the function. After you train, you use the function classify. Classify is the function to run the network. So you're gonna give the net, exactly what we train, and the validation data set. So the answer of this is gonna be the result of validation. Let's complete. Let's calculate accuracy. So validation is gonna be the labels I have. So this, if you click, if you press dot, it's gonna give you what is inside this variable. So we have folder variable, we're gonna use the labels. So if we go to validation here, you will find these values. So you go to labels, you have the labels here of the data in the validation. So now let's make an accuracy. It's a sum of the, we are comparing if the what is inside this prediction, if it's equal to the what is in the validation. And this sum we're gonna divide by the number of values in the validation. Okay. So what I'm doing here, I'm comparing. First, compare the result of the classification and the result of in the validations. Let's see equals means. Let's see the output is the same. So if it's yes, it's gonna give me a value of 1. If it's not, it's gonna give me a value of 0. And I'm gonna sum. It's gonna be a vector. So I will sum this, and it's gonna give me a number. And after I divide this as the number of validations. So let me run this and explain later. So I run it and gave me accuracy of 99.04%. Okay, for you to understand it, let's see what happened. I'm gonna enter the net. Net is our network. Here you see the layers, input names, output names. Inside the layers, remember we see weights and other values. Or where are these weights? Convolution. These weights are inside here. So remember the bias and the weights I told you. So this is the values that the network has learned. Okay. So remember we make these filters as 3 by 3. So you have 3 by 3 here. Here you see 4 dimensions. Okay, because you have we have 3 filters. So we have this kind of multi-dimension data. So one filter, another filter. These are the weights. And you want to know the bias? Also we have the bias. Sometimes it's a 0 values. Sometimes it's very small, sometimes it's very big. Okay. So this is the same for the convolution. First convolution, the row layer doesn't have anything. The max pooling gives you the window just in the stride. And another convolution gives you different weights. Okay. So these weights will extract some features, different features, and the classification outside. So 1 to 10. How many classes? 0 to 9. So if you go 3, you want the values of the filters. In Matlab you can access easily them. Wait, okay. They are here. Another thing, let's explore this prediction. So why it's in YPRED? We have values, zeros, and sometimes we have one, let's see, ones, 2, so it's the number of the output. Let's see if we have something wrong. It's going to be kind of difficult to find this. Oh, here, there is one. Yeah, here. For example, here there is a 6, should be a 6, but it was classified as 1. Okay? We don't know which one is this image because we are not, it's random. Okay? So this is one value that's going to be different if you compare with the validation, V validation, Y validation here. Now let's compare side by side. But let me go to this value. Here, for example, you see the 1724 should be a 6, and now it's 1. But this is an error of the classification. So that's why we compare. So if you do this option and we run evaluate selection, I can do this in Matlab, okay? Let me teach you again. You click, hold, and just select what you want to do. You evaluate. It's gonna give you an ANS value, okay? You didn't assign to a value, so this is the ANS. If you go there, means 1, 1, let's go to the 1724. You see a 0 there? So compare YPRED with the Y validation, it's a 0, so it's an error, okay? So this is what we've done. We compare and we can count how many ones we have, and we divide it by the number of values. It's 2,500. It's 25% over there. So now in this, we finish our first neural network. I don't know if it was difficult for you, easy. I believe you're gonna face some issues here to type errors or type errors. So I recommend you to go to this one if you miss something and you have all the code over there, okay? The next, now we're going to do this on the app. Just give me 1 minute. Okay, somebody asked about confusion matrix. If I can show, I will show in the next example, okay? Because we have some time, so it's already, we have 1 hour and a half more. And we have 3 models, 3 demos. So let's see now in using the app, okay? So what are you gonna do now? You're gonna clean up everything. Let me show you how to clean up. If you want to save what you have done in Matlab, you can click here in the home, save workspace. What's gonna be done with this action? You're gonna save everything is here on a file, on a mat file. And after, let me make my files. Save. I recommend you to do that, okay? So you will not miss your files. So it's saved. my files. It's not a lot. And now let's clear what we have. So if I write clear and press enter, I'm on the command window down here. Okay? It's gonna clean everything in my workspace. So my data is gone. But if I want to bring it back, I save it. So it's here. What I can do, I can bring a separate values. So let's bring only my neural network. Just drag it here. When you drag it, it's here. And you can release it on the command window, or you can just write this function. It's gonna see in my files, bring the net. And you want to bring everything, brings my files and bring it to the here. Now we have everything. What was there was the net was substituted again for the next net. Okay. And now let's go to the, so let's clear it again. Clear. And CLC is gonna clean my command window as well. Okay. So before that, let's run once. I believe we will not run because I have the data. So let's export it as a PDF. So imagine you had an assignment from university, and you need to generate a document. So you need to put everything in a Word document, and you need to deliver it to the system, deliver it to your professor, or print it out. So let's go to the home. Now Live Editor, click here and see Save. Save as PDF. Click there, it's gonna give you, want to save as this name? Yes, save it. And because you already run it, you have the values there, it's gonna print the PDF. So you have everything in a PDF. Very good. You can write your name here. You can write what is the assignment. You have the professor will see the code you wrote, and also your comments in the code if you have. Okay. Let me see. This is very good for the assignments you have. Okay. Some of them have this kind of problem, but this is the result. If you don't want to have the results, easy. If you use this. Live Editor. And this section you don't have. You need to go to Matlab and use the publish is available. Let me see here. Here, how output inline, hide code. I can hide the code. I can hide the output. I can hide the inline. Okay. Hide code. I don't see the code. Hide inline. Output. You see? Or output on the right. You can do it here. Output on the right as well. So you see here the line of code and the result. Okay, on the right. Or down. Okay, so next, let's clean it, already cleaned. Let's open the app and let's build the layers there. I believe it's gonna be faster than doing the code. So you're gonna have some apps here because I have all the toolboxes. So Matlab have very good apps to make you write less code and make you faster. Yeah, Matlab has this speed up development. This is what is the mark of Matlab in Simulink. It's going to be speed up the development using the apps. You less type less code and enjoy and see more and spend more time to understand what we're doing. So here you're going to find the machine learning and deep learning. So this is gonna find the deep network design. Click there, it's gonna take a while to open. So here is, you have the pre-trained networks, as I show you during the presentation. And also we're gonna start with a blank one, okay? So we have some, let's build a network by layer with what we know, so what we did before. So we have an input layer, image input layer, remember? And let's bring everything back. Input layer, we have also convolution to the, after we connect and configure it. So we have a batch normalization layer. This is batch normalization layer. And we have a ReLU layer. Okay. Now we have a max pooling, max pooling to the layer. Okay. Now remember that, let's copy this. Ctrl C, Ctrl V, have a copy, let's put under this. Because the same, remember? I think I need to make it closer to this, okay? Now we are doing now we're gonna copy only this part, we have 3 layers, Ctrl C, Ctrl V, and bring it down here. It's becoming some far away, yes, because this kind of linear, you can make it like on the other side. But I prefer to do like this for better understanding. Now let's bring the, after the ReLU, we have the fully connected layer. It's gonna be between inside the fully connected layer. And we have the soft max layer. And the classification layer. Okay, we are done. Now let's configure them. The image data, remember, is 28. You need to put the comma here, 28 and 1. Was only this. The convolution layer, the first one is, the filter is going to be 3 by 3. And here the number of filters, the first one is 8. And also we have the padding same. Don't need to configure anything else. Here don't need to do anything. ReLU, max pooling, we need to have a filter of 2. 2 by 2. Oh, sorry, 2 by 2, and the straight also 2 by 2. So if you get lost here, go back to the code we just finished. We are adding this values there, okay? Max pooling, this, exactly what is inside this, we're going to add in there. So now the next one is going to fill this 3 by 3 and 16. Let's go back to the next convolution. 3 by 3 is already there, and it's going to be 16 output. No, 16 number of filters, sorry, adding the same. Max pooling, the next one is going to be also 2 by 2. And the convolution, the last one is going to be 32. So 32 is here. Don't need to change anything. Now the fully connected layers, here in the end, needs to change to 10. It's already 10. Okay, perfect. So now we connect this. So it's going to be a sequence. Just this. You see, it's going to appear a small dot here. You can just drag it. if you are doing this, if you prefer to do the coding, no problem. If you do the coding, you're gonna have this this result. So here, like, also you can move them if you want, seeing the same. Okay, you have, sorry, let me move this. Okay, I don't know what I'm doing. Okay, so this is the row shows you what is the sequence, but also you can go to auto range, poof, it's gonna auto range everything. Some of them, some of you want to be very good like this, some of them doesn't matter. Okay, so let's analyze the network. So here is deep learning network analyzer. So it's very good in Matlab. It's pre-built there. You're gonna show you the layers you have and the warnings and errors. So if you have any error there, you can solve. It's gonna give you a warning or an error. Okay, if it doesn't, something, the input of the one layer is not the output of the one layer is not the input of the next layer, is going to give you an error. So here the convolution you see 28, is going to receive the next convolution 14, 14, 16. The next convolution is going to be 7, 7, 32. And here's the weight, the bias we'll have in the convolution. The offset of the, it's just the best normalization. Now, let's bring the data. Remember the data, let's import from image data. Let's point the folder. Also, you can do the image storing workspace, but we have a folder. Browse the folder, GG dataset, select the folder. And this is very good. So split the training data. Yes, let's split. So specify the amount of data for validation. So let's use 25, the same as before. Random, yes, let's use random data. So it's what it means gonna get, each label is gonna get 25%, but it's gonna be random, not the first 25% of the last 25%. And there is another augmentation point, but we'll not do it. So let's import the data. Look at this. This is very good visualization. It's going to show you the number of data. So we're using 750 for each category. It's balanced. We have the number of all the data. This is very good when you have data like this. And also show you some of the values. All classes. You see zeros. I want to see the 6, number 6, number 7. You see some of them are rotated. Some number 7 looks like number 1. So you see how important it is to, then sometimes like a person will say this is a 1, but the machine will be trained to understand that this is a number 7. 4 is also, I think 8 is something people write different ways. 3, I don't know. Okay, so let's go to the training. Here we need to add the training options. Remember we have training options over there as well. So let's go to the SGDM. Our initial rate, let's keep 0.01. The max epochs, let's bring 4. Validation frequency is 30. Mini batch size, keep this number. If your machine took a lot of time to train, because the processor cannot handle a lot of mini batch, so you can reduce the number to 64, to 20, 10, as minimum as your machine will be able to process. Execution environment, GPU, CPU. You can train CPU, but it's going to take, I believe, 10 minutes or 5-10 minutes. So I believe GPU is faster, 19 seconds. And here is what else we need, epochs, shuffle. Every epoch, shuffle. And what else? Okay, guys, I will go slower, okay? So take a look at this configuration. It's the same as we have here in these training options, okay? To get lost, do this, follow this. And we'll finish. So we have the designer, the data, and the training. When I finish the option training, we can train it. If you miss a point here, I encourage you to see the recording. We're going to provide the recording after today, later today or tomorrow. Okay. So now I see this within the app, the training progress. The training progress is not always the same. It changed, but you cannot visualize. So you see the light blue is the training, and the darker blue is the smooth training. Smooth, so you just see a smooth the curve going up. So it's finished for me. Let's see the accuracy. 99%. Remember, last time we got 99.04%. Now we have 0.04 less. So what's next? We use all the app. We didn't code anything. You can imagine that? That's very good. And we go to the network trained model after the results. Probably you're still training yours. If you are running on a CPU. Okay. So export the training model. You can do two things. Export the training model. If you click there, it's going to give you exported trained network 1 and trained info structure 1. Okay. So let me minimize this and see. So the network is ready. But this is the network. We're going to let's run this, okay? But to do that, we need to bring the data again, because the data is not here. So let's run the first image store, run and add events. So let's run this. We don't need to run this, but we can run. Let's run this, image data okay, and number of files. Okay. So just run until here, because we need the validation. And here, let's go to the end. So you can run everything until specified training and validation sets. Okay, so now let's test our training in the app. Now you see it's called net. What we can do is the net is called this name now. So what we can do, we'll copy this, Control-C, Control-C. Let's write down here. Don't mess the code. Instead of net, let's write down a trained network. If you press the tab, it's going to fill the values. Okay. So it's going to classify my validation. Let's press enter. Classify. Now let's run this while validation again. You can run like this, evaluate selection command window. It's going to be copy here. The first one I copy and paste because we need to change that, okay? Now, let's calculate the accuracy. Evaluate. So you see, we got very good accuracy on the validation, more than 99% of the training, 99.48%. This is very good result. Another way, remember, we can see, okay, we're still in there, don't close it. The good part of Matlab is you don't need to code a lot. Use the apps, and with the app, generate code. So if you see export here, you're gonna find a generate code for training. You're gonna find this in all the apps. Generate code for training. You click there, it's gonna give you, okay, I will generate a code, a live script, and also I will put the training files, the net and everything in this value. So let's give a name. Sorry, Control Z, because I want to change the name. Let's keep the same training setup and the date and the time. So generate lab script. So if you minimize this was generated automatically. So everything we've done is here. So when you see the text is different. It's an image store load and export data, but keeps you loading initial, separated in very good breaks. So load initial data, import the data. The data is taken from the file. So if you close this, if you clean this, clear. Look at this. And I run this section by section. Import my data setup. It's gonna import my image. It's gonna make the options. You see, it's quite, it's more robust. Now we put the name of the values. So this is the only thing that changed. You can give the name of the layers. You build the layers, and you can train. I didn't need to code anything. Everything was within there. Okay? I'm gonna open the training again. And that's it. So what I want to show you is that Matlab from the app can generate the code. Okay, in this designer, go designer, after go to data, and there you see visualize your data and train, and generate code for that. So, and this the code you just generated, you can create a report of this, make your modifications on the text. Oh, 99.2 is not never all the time the same accuracy, okay? Because the path is different sometimes. The data is different, it's random. So here you make your modification. So my name is Flavio. I have this is gonna be a heading, and also I need to, this gonna be my report and my assignment, and you can export as Word. Let's put as Word now. Word document. So after you finish, it's gonna open Word, and you see here, it's a report. You have everything within Word. Parameters. This table is not that put in Word. Okay. So this is what I want to show you, that how fast you can be in Matlab or to do your assignments. And this is very fast. So next, let's jump for the next. I will not save this. Let's clean this. So the next one is gonna be the transfer learning. So transfer learning, the approach of creating a learning feature. So this is gonna be instead of doing this training of a neural network we already have from AlexNet, we're gonna use a pre-trained. It's gonna be AlexNet, and we're gonna change a new task. For example, this is an object recognition, car, truck, bicycle. You can use the same to train with new data to classify dogs, images of dogs and cats. This is possible, and I encourage you to do this. It's less time. So we already went through what is the transfer learning. So what we're gonna do? Use AlexNet to classify flowers. Transfer learning with this. So we're gonna have AlexNet. AlexNet is a network for 1,000 classes. Have a lot of different classes, and now we're gonna train to classify types of flowers. So this is something that you can use for many of your applications. We want to classify cars, want to classify or want to classify a different thing. So let's jump to this. So if you go to the material, I need to run a little bit because we have 1 hour. And transfer learning, let's click there, transfer learning AlexNet. You're gonna find some files. I have flowers. In the folder flowers, you have all the flowers you're gonna use. You cannot smell them, okay? They are like bits, virtual flowers, okay? But you see what is inside. You see this very good image of flower. You see it's very good quality. It's 227 by 227 and have colors. So for example, if I import one of this image, like image equal to, just let me show you, image equal to read, image read, sorry. EEM3, then typing. What I'm doing. Now we need to, what is the name of this file? Just copy this. Do this, I do this, rename, copy. I don't rename, I just copy the name like this. Sorry, this function is wrong. Okay. Okay, this without this. Okay. Okay, EM read. So I will not put the semicolon. So you see all the values. You see, it's very. If I didn't put the semicolon, it's going to show me the matrix. What is the values under the image? So if you access it, it's at 227 to 27 by 3. 3 dimensions, RGB. So let's visualize this using the function image show. So image show, no, image tool of the image. Okay. So if you press this image tool image, it's gonna open up this small tool. Let's make it larger, 200. So 400. So the image have 275, 27, 227 in 3 dimensions. We have a small inspect pixel values here. Click there, and it's gonna give you this small window here. This is very nice to explore that the image is a mix of colors. Let me make it smaller because we're gonna go to be able to see this. So it's gonna open this other window. If you move this, you see you're gonna have the RGB values there. So you have this value gives this purple, this value gives the green. So your green is high, red has some right, white is almost 255 everything. Dark is almost low values, almost 0. Not very good dark. You make it bigger, it will not show. See how many pixels have. Okay, so this is nice to explore your image. These are a curiosity. Okay, let's jump to the algorithm. Now we are in the transfer learning AlexNet. Let's open the train flowers blank. Here we're going to add this to get the image. So again, we're gonna call it now the flowers flower data store DS. Gonna be equal to image data store. Image data store, and it's gonna show me flowers is there. We're gonna finish here. Sorry. And let's include the subfolders, same way, true. And now let's label source is gonna be the name of the folder. We're done. Okay, very fast. I import the image now. I import the location of the folder. I'm not importing the data too much. This is very important. So you can deal with very large data sets. You have another option of using power arrays that you have very, very big data sets you need to process. Don't need to bring it to memory. You can bring it as small pieces, process and delete it, and bring it again. The next batch of data. So Matlab can deal all the amount of data you want. Doesn't have this limitation. Now let's split the data set. It's gonna be a train images, and the next one is gonna be the testing. That's our name of our data sets. Let's split the same one function, split each. Sorry, forgot to split each label. Now we're going to do in a different way. Now flowers, and we're going to provide a number of 0.6. Means this 60% of the data is going to the training image. So the first. Okay. Let's run this. If everything is smooth, yes. So it's running everything again, yeah, in this. When you run section, it's going to run everything in this section. Number of classes. Number of classes is just a numeral value of the categories. Categories. labels, yes. So let's run this. Okay, so we have 12 classes. If you go to the folder, we have 12 type of flowers, blue, bell, and tulip. Now let's use AlexNet. So I teach you how to go to the home and add-ons, but also if you want to know AlexNet, you can click directly there. This link is not opening because my browser. But if you copy this link, okay, I'm inside this train flowers blank, okay? Copy this link and open it within the browser. It's gonna arrive to the file exchange, you can download it, and you're gonna have this file. This file, you can just drop it here, and it's gonna start the installation of the AlexNet. Okay. Sometimes within a company, this doesn't work because it needs access to the Matlab server. Some companies have blocked all the ports, so you don't have access. So now let's use the AlexNet. Net, I will comment let, is going to be AlexNet. And run this. So what is doing? The net, AlexNet is a variable there. So AlexNet is the network. So I assign my net to be AlexNet. So you see how many layers have? So we don't need to build anything. Just let's modify the last outputs. Okay. Modify the layers. So now we're gonna first let's see the layers we have. Yeah. So layers is gonna be net dot layers, and let's see what we have inside this. So we have our input image is 227 by 3. It's okay. We have this as our image have this size. Yes, 3 because 3 dimensions is not showing here. And we need to, so here we need to change. The 23 layer is a fully connected layer. It's a 1000 fully connected layer. So we will not have 1000 outputs. We'll have 12 outputs. So modify the classification and output layers. So the layers, the end, so we're counting the last one minus 2. So to reach the 23 one, it's equal to fully connected layer with a number of classes. So it's going to be 12 instead of 1000. And the layer in the last layer, the output also need to be to have only a few outputs. The last one going to be the classification layer. And we don't need to set the number of outputs because it's set automatically. Okay. Let's set this first. Okay, we set. Now we have layers in net. So what is layers? Layers are the layers of the network. In net is the already trained network. Okay, we have the weights here. You see, in very large filters. So let's visualize this on the app. Again, let's go to the deep network designer. We click there. So let's open a blank network. Here we have let's bring the layers. So we have new here from workspace import. So we need to do this. So we have the net and the layers. Let's bring the net. Let's see how is AlexNet. So you see, we have AlexNet here. So I need to press Control and zoom, okay? So let's see, the input layer has already, you see here is something you cannot change, but let's see the last layer. Is the fully connected, have 1000 values. Here you cannot change, you need to go there and change it, okay? Because this is coming from the one. The classes you see is a tank, called goldfish, great white shark. You have so many outputs. So many classes, yeah. So now let's open the one we change. So import layers, okay, replace. So what's the difference here is the last layer we change. Fully connected layers, we have 12 instead of 1000. And here is out, class is output. Class output is auto means that what's coming from this layer, this layer is going to be the output. Okay. So this was, we opened the tool just for visualizing. If you analyze the network, it's going to give you all the weights. Okay. We have 96 weights, like kernels of 11 by 3. So this is what it says. We have 96 of these 3 dimensions, but we have 96 for value. And here, let's go the fully connected 12 on these values in the output. Okay. So is everything fine? No warnings, no errors? Let's close this. We can do the training from here, but we're going to do by coding. So now we modify, let's go to setting the training options. So here I did a test before. Options. Going to be equal to the training options. It's going to be the first one, the SGMD. After we're going to have the initial learning rate. Initial learning rate is going to be a small value, okay? So now it's going to be 0.001. Now we're going to do mini batches because this also, we're going to set the max epoch, so let's mini batches first. So it's going to give, it's going to run 10 images per every time in my memory. So if your memory doesn't support this, please make sure that you can reduce this number. Okay, max of epochs. Let's change to, let me see how much I need to change. Let me see this string flowers. Need to change to 20 and that's it. So 20 epochs. Now the plots, let's see the plots. Let's see first. 3 dots, let's go there, plots. And it's gonna be the training progress we want to see. Now is the important part because this is quite heavier than the first demo. The first demo was not a lot of data. Now is each image is 100 times, 1,000 times bigger than the first one. So now let's see the environment of execution environment. Now we're going to set auto again, but if I set GPU, it's going to be the same thing because I'm going to run my GPU. For you, what I did a test of how long it's going to take for a GPU and how long it's going to take for a CPU. In my CPU, it takes 15 minutes, and my GPU takes 2 minutes. So for you, probably if you don't have one GPU, so it's going to take a little bit more. So let's perform the training. Let's gonna do this. My net's gonna be called flower net. And we're gonna have some additional info. So it's gonna be my training network. My train network is gonna receive the train image. I split over there. It's gonna receive the layers. I just change it to classify the flower types and the options. So that's it. So I would, I think I didn't run this. Let's run these options first. And the layers are already changed, right? Yes, layers are here. We go to left one and just check. 12 is okay. I changed that. Let's run it. So my GPU, it takes 2 minutes. Let's see how it behaves. You see, now it takes a while to reach a good accuracy. So it's still going between 70%, getting to 80% after going through the data 3 times, still going. So it reached at some point 100%. Also, if you go to Matlab, you can see the steps here, okay? So if you don't set this plot to be training progress, this will not appear, okay? If you set variables none, false, this will not appear. Sometimes it's good for not to appear because it consumes some of the graphics of the machine. Okay, so we went through half of the data already, 500. Okay, I'll be back in 1 minute. Okay, guys, it finished 2 minutes and 48 seconds. I don't know, it's showing the no accuracy, but here you can see the error is very, let's see the rows. So it says 100% accuracy. Maybe because it's not a lot of data, it's not a lot of files. You see, we are training over 500 files. So this can show that there is some overfitting. So if you have deep learning, you need a lot of images. 500 is not a lot. You need thousands sometimes. This AlexNet was training with 1.5 million. It's a lot. So let's check. Use the training word to classify the image. We need to check if accuracy is good and also plot a confusion matrix for that. So let's test it. Let's use the test first, yeah? Test facts predictions. We're gonna be classified. Now we're gonna classify, where's my name of my net is flower net, right? Yes. Flower net is, let's give the test image. So let's do the classification. So here, let's evaluate the results. None is not a zero. This is non-zero function. That's a different way of doing the prediction, to counting the number of predictions. So now I'm counting what is not zero. What is not a zero? It's the same as summing, but without we're gonna divide the same. Oh, sorry, it's not this one. Is it test images, right? Yes, dot labels. So now I'm doing directly the labels, comparing the same as we've done before. And it's gonna give me, I'm gonna divide this by the number of images. If the test, right. Okay. So let's see this. It's accuracy. Oh, you have accuracy of 75%. You see the net will show us 100% for the training, but for the testing is giving 75%. You're gonna face this many times, but let's see what exactly is happening. So what is missing the information? To do, we're gonna do it upload. Sorry. To do so, we're gonna plot a confusion matrix. We're gonna call the flower net. Sorry, flower. I'm gonna call the flower. It's gonna be an output confusion matrix, and it's gonna be the flower names. So this is gonna be my output. This is gonna be a confusion matrix. And I need to provide the test images first with the labels and the predictor, the prediction. And this, we're gonna use the heat map function to plot the flower names with the flower names against with the flower names. and with the confusion matrix. Oh, sorry, it's not this name, it's the flower conf. Okay. So let's run this. So here we see confusion matrix. So what is in the diagonal is going to be is selected good, what is not very good classified. So here, for example, here we see the tulip is confused a lot with the daffodil, the name of the flower, and the buttercup. That's weird, yeah. Let's see on the files what is exactly. So let me go to the folder when I have. When I have the image. So AlexNet here, flowers. So I have this buttercup. So it's a yellow flower, looks like this, and it's confusing with tulip. Oh, okay. Now we see the flower is similar. Looks like, for me, looks like similar. So for the color is the same. Probably this is why some of them buttercup are the tulip. Let's see tulip and the daffodil. Daffodil. Yeah. Also is yellow. So you see, the flower looks similar. So probably we need to provide additional information because this network is going to receive only the image. If we have more images from these flowers, it's gonna have better results. Otherwise, we need to think about providing a feature of the color of the image, a map of the color of the feature, but also it's going to be the same. So we need to see what is the difference between these flowers. And also we have Pansy here, no, here 11, Crocus and Snowdrop. Crocus here, it's a purple flower, and sometimes it's white. Sometimes you have many, sometimes you have one. I'll have something yellow here as well. So let's see this. This is the crocus. Let's see the snowdrop. Snowdrop. So it's white as well. Sometimes have many flowers. So the images probably is getting the white, and also is getting the amount of flowers you have. Okay, so this is what you need to think about while you're doing. Sometimes it get confused, yes, but it's because the image is learning only for the data, from this data, and the data looks similar even for us. For us, it's very difficult to classify these flowers. The machine, I think, do a better job than us. Okay, so I have a matrix, so you know how to have a matrix of the results. Okay. Now let's now we use AlexNet. You know how to use AlexNet. Bring AlexNet to the workspace. Copy the layers, change the layers, and do the options, the training, and you're all set to test. Now let's jump to the. We can also generate a Word document. Using a Word document like this. And now let's jump for the two other examples. So what kind of flower is that? We have very good image here. You need to resize probably this, see? But it allows to have some resizing. Okay. So you can imagine this is your report with few steps. Now let's jump for the, if you have any questions about this, please go to the chat, write it there. After the session, I will take a look on the chat. Also, my friend Hassan is helping a lot with the answering the questions. Now let's jump to slides again. So we finish this. So now we're gonna use this feature example of the YOLO version 2 for detecting objects. So we're gonna, we will not write line by line because it's quite complicated, this demo. So this demo is using also transfer learning. And let me show you also how to label your image, your data. This is important. We'll have to do this open script part 1. And so let's clean everything. I have something here. This is just the command of clear, close, and all in TLC. Let's close the training. I believe your machine is making some noise as well because all of this training. Now let's go to the here is called this folder, deep learning overview for images. Click there, image and video. Click there again, YOLO. We're gonna find some values, some files. So let's open the part 1. Click twice. And it's also it's a live script. Part 1 data preparation, and also this configuration. So we're gonna open as a project. So if you're running this for the first time, probably it's gonna take a few minutes. So let me run in advance. So running in advance is gonna bring you this. You're gonna have an option of do you want me to copy the data? And say yes, okay? Want me to copy the data, say to the folder, yes. Probably because of this copy data set. So just continue, yes, whatever it showed to you. So what is this? This is it's a way to work with Matlab as a project. So you can analyze what you have, all the files, they can combine and see what is the dependencies. Okay, so here is what is this project? It's the analyzer. So here you have so I'm doing this with scrolling and it's a folder I can move it. So here I have some C code, the C++ code, CPP. We have the code of Matlab. MLX is the TypeScript code. We also have M files. And here you can do the not see Matlab code. What is data? Don't see the C code and just see the Matlab code. Okay. If you enter, you can call the parts from here. Just click twice. Okay. And also you see the parts. So let's go to this. First, we call the project, run this. Now, what are we gonna do? We're gonna use the image labeler. There is two options to open the image labeler. First, you just bring the IMDS. This is data store. And bring the vehicles images. Let's go to apps. So the image labeler is within the image processing app. So here you have threshold, color, image acquisition, view, video labeler, image labeler here. So you click there, it's gonna open an app. Okay. So here we need to load where the data we want to load. So, but I'm gonna run this because this is gonna run and brings already the data there. So let's go to live in the run section. A lot of people are looking for something like that for a label images. This is a lot of work, believe me. But when you are ready, you label everything. You can build very good deep learning models. So here, what we have cars. We need to create a label. So let's create a label of cars. It's going to be a rectangle. Can be pixel label, can be projected cuboid, can be. So we will not group, just select a rectangle and the way it is in car. So what it means, I have a car here, you see, it's the picture is not very good, but it's a car. So you go there and select the region where is the car. Okay, let's see better images here, select the car, go to the next one. You can imagine doing this for thousands of images. Or this is another car, this is another car, and another car. So this can take a lot of time, effort. So what we recommend, if you have already an algorithm to detect this, you can use it. There is an automation task for labeling as well. If you have the selected algorithm here, find this ACF Vehicle Detector. Okay, so you can people detector, and also you can add your own algorithm for automation. So if you already have a detector, this detector sometimes is not for cars. It's not a deep learning model, but it's based by color. For example, for this application for oil and gas, you have some samples of microscopic soil samples. So you want to detect the number of pores you have in this soil and this microscopic sample. You have some color that is exactly the tagging of this pore. So we can go there and select the pixel segmentation and automate our algorithms to segment everything is color in blue or in another RGB value. Okay, so let's add the vehicle detector. And clicking we need to select the number of images. Let's select, we have so many images here. Let's select a few of them. Here, for example, this here, shift until here. And let's automate. I select the image, I select the algorithm, select the image, automate. But for this, I need to have the label. Now what's gonna happen? If I run, I have some settings. Settings for detector of the model, full view, front, rear view. So we can select this. You're seeing the full car or just the back in front. So let's see back in front. Overlap threshold, so you can give a threshold of values, classification, score threshold. Bring me what you think is more than 65% accuracy. Give you an accuracy. So bring me what it is. Okay. So let's run. It's gonna run over all the images, and because this is something available. So here it detected a car. It's correct. Here didn't detect. Sometimes here detect as well, but sometimes the image is not very good and doesn't detect at all. So if you change the accuracy of the images, we can set this. Well, if you set this, what do you do? It's an interactive way to labeling. You can set here, this is also a car, this is also a car, and we accept everything. And when you accept, you will have the label there. So after this, you can export the labels to a file or export to a workspace, and the workspace is going to be a ground truth. And how is this label? Let me show you. The ground truth image is going to give you a label data. So you have the label definitions. So it's going to be car. It's going to give you exactly the label color. So this is RGB, just the yellow color. And this is the label data. So we label a few images on. And what's saying in this is the data source. So you have the source. This is the image, number one. From image number one, we label this part. So this is just the location of the rectangle, the box we draw. So this is this Y and X and the size. Okay, so we have the label image. So this is enough for training the algorithm. So this is something you may use. Okay, and closed. I will not save the session because we already have the label data. So this we went to part one, vehicle detection, labels. Now let's open part two, is the modeling part. So now here we're gonna do the training and evaluate the model. You have the options, so we're in this part of the workflow. So you have the option of clicking to do the training or to do the import of the YOLO live from another framework. Let me see here. We're using this. Here's the model. So the model of the YOLO is in this on and X format. So you use the import on an X network to import. Okay. So what it's gonna do? I will not do the training here because it's gonna take a while. We have only 20 minutes. So do the training. There is an option to set yes. I will set no. Okay, 0. And import network. Okay, let's import it. So try this again. Run this. Go to the load data set, run this. So it's gonna bring the images within this here. So I have some cars here, vehicle images. Now data preparation. So let's do the partition of the data. 50% is gonna be hold out. Hold out means that it's gonna be 15% of the data is going to be hold for the validation. There is holdout, and there is also the K fold. So go to the documentation and exactly go there in partition, help, and you can go and say what you want, K fold or do this holdout. I'm going to give you what is exactly one of these. One of them is when you have a lot of data, the other ones you don't have a lot. So data preparation, let's run this. Data stores. So let's bring the image data for training, the image in the labels. This is inside the image file. Sorry. Okay. So we run this. So it's bringing the data to Matlab. We're not doing just bringing data. Data that already was trained before, okay? Because this model takes a while to train. So now we're gonna explore the data. Let's read the rectangle box that is in the data on the training. I'm gonna show the image. So it's gonna show me the image with the annotation. So this is an image and with annotation, okay? So this is the, now we're gonna create a YOLO detection. So you can import directly to the deep network designer. And also you can import the feature extraction. We're gonna import directly from the model on XX. I believe it's here. So this is the model. Okay, in this format, exchange format. Let's bring it. So give you a warning, but it's okay. So what's going to be the name is base network. Base network. So these are the layers. The layers will have, let's see how many layers. Wow, wow. 179 layers. You see, we work with 15. After we work a little bit more, now this is a lot. So convolutions, layers, batch, regulation, max pooling, convolution, and repeat this many times. The first one, you can see that padding size, the weights. Okay, so we have the values there. Now let's remove layers. We're gonna remove this 120, 140, and let's load the, gonna modify the gonna remove the layers and bring another layer, another network for detection. So what we need to adjust the, I encourage you to filter. I'm going to just speed up a little bit because we have another model to see. Create convolution ReLU. We jump to this. And also you have number of filters, detection layers. So we have two chains on the layers to detect cars. Here, the last layers. Actually, we are detecting layers with a few layers. We are getting some layers to detect. And also the boxes of where is the section of the box, where is the annotation of the data set, of the label, sorry. And now let's add the last layers. So final layer is gonna be these layers. So our detection is gonna be 9 layers. Let's analyze the network resulting on this. So we have the input data, 179. No, we changed some of the, we changed some of the nodes, okay? The last ones. After we do the training. I will not do the training because it takes a while. I will just run an advanced this, and it's gonna bring the load data of the pre-train. Okay, the detector was already trained, and here I will run it. I'm gonna do the classification. Sorry, I'm gonna do this. Test the model accuracy. So have a car here, for example. Let's see the model accuracy for this car is 87%. Here is a slider. You can change the image. 40 images. And you see 81%, 91%. So it's quite good detecting the back of the car. I don't know if there's some front view. There is no front view. You can imagine you want to count the model of the car, and you can make a prediction and put a camera on the street of your city and count the number of models of cars you have around. So if you have this data, you can do it. Okay, now let's evaluate the detector. And let's plot the evaluation. So this model, the way it was changing the last layers, gives you a 89% accuracy. Okay, So I encourage you to go slower to this code and understand what is being done here, because we have a few minutes. Let me go to the part 3, which is the deployment part. This is interesting to see, generating the CUDA code. So here also let me run this. Part of the project is important to bring the right path for the code generation. Here, don't need to code. Okay, if actually this is a code generation. If you run this function, you can run. It's going to open an example. Exactly, this is the code generated. So this is inside the GPU coder, and you have how to generate the code step by step of the functions. What you need to do before. Yes, you need the Nvidia Toolkit, the CUDA DNN. Somebody asked this on the chat. Yes, you need. You can install it. It's for free. You don't need to pay for that. And this is, you have some of the setting up prerequisite products and third party. You will not be able to run now because you need to set this. And let me go back to Matlab and see what is this code. So I have a report here that's show me the CUDA code. So here we have the YOLO detection. Here we have the files for the code. So it's a GPU. So we have the code, and let me see here is respective to the YOLO v2 detect. YOLO v2 detect CUDA code. Here show you C code for max. So see the max code. So this is the CUDA code. You see how complicated it is for one function here, and also have other functions inside it. How many functions are generated for CUDA GPU kernels? So if you see, it's very difficult for a person to write all of this. So because you have to write where are the boxes, you have some images there. So this is generated automatically by Matlab with GPU coder. So don't need to worry about, the code is very robust. It's gonna, you can try it out on your GPU after that. Okay. You have many other values here, the headers, the other files, GPU kernels, kernel 1, kernel 2 is going to give you the kernels of the convolutions. Okay, so this gives you a very good code. Also, you have code insights, entry points, settings, your GPU code metrics, CUDA kernels, and for every file, or the thread dimension, the blocks dimensions, and a lot of very good information. Entry points. You need to enter just an image. This is the entry point. So just the image of the car, and it's going to give you a result of the image. Actually, it's going to give you another image with the annotation of the car. What is with the rectangle? What is the car? Okay. So explore this report as well. When you're finishing your work here, don't save it, okay? Save the workflow if you need, but don't save this file. Otherwise, you need to unzip it again if you do you mess it. So don't save it. Okay. Now let's go to the last 10 minutes we have to the one of the signals. So, we generate code. Let's skip this. Now let's work with signals. Signals are voice, can be health monitoring, coming from different devices, can be from your voice as well as a signal. And we have some apps in Matlab to do the count through of labeling of signals. You have this in your license already, in your trial license. So you want to, it's called image signal labeler. Okay. So this is something very helpful. So you can label, and also we have for audio labeler. So you can say this part of the audio is true, is yes, no. Remember this demo in this video in the beginning of the day. So exactly this one for up. So this is the recognition of the audio.
No. Up.
Up.
Right. On.
Okay. So what is the workflow for this speech recognition? You have no, you provide the data, yes, no, up, down, left, right, compute the spectrogram of this data. Spectrogram is going to be an image, like any image we've seen so far, 2 dimensions. And also we have the 3rd dimension of colors. It can give a good data. You need to augment or to give to do a data augmentation if you want. This means that to bring more samples to the training, and you build the network, you train, and you evaluate the performance through this by seeing the confusion metrics. Okay, and deploy it. So let's go to this classification of air compressor sounds. We're going to use a long-term short memory network, classify sequence data for anomaly detection. Let's close this yellow here project. Open the overview of signals and time. Here's the same. We need to open the part 1, part 2, and part 3. Part 1 is gonna address some of the. It's gonna open the project. It's gonna do some of the feature extraction. Let's not do feature extraction. I will explain you this. Run section. So I run this. It opens my project. Okay. Continue. I can analyze it again. The files. This file has some. This project has some C file as well somewhere. Okay. So let me minimize this. And let's go to the network. Here we're gonna create a data store. So all the data compressor is sound data. This sound data is means that the sound of the compressor, like bearing, is a WAV. It's a, I don't know exactly what it means this, but it's audio. Okay, extension. And we have piston, we have audio piston, we have reader belt, flying wheel. So we are detecting air compressor audio. So create a data store. Now we're gonna use this audio store. I will run a little bit, we'll have 2 minutes. And after we're going to do this, split the data into validation sets, as we've done before. Now the data preparation. So humans insights, you need to know what this is a signal. You see, it's very messy. We're not able to do. If you play this like this, sound, simple data, evaluate. I don't know if you can listen, but it's the audio, one part of the audio, in this sample. So we're gonna use long shortened memory. Why? Because is good for signals, and it's gonna have a time memory. So time is a variable as well. And generate training features. So what's gonna generate from this? There is an audio feature extractor when you can generate from audio some spectral decrease, spectral centroid, slope, spread. So if you visit the help of this sound, you have so many features you can extract from audio. Use these functions from Matlab because it's gonna be very easy for you. Don't need to write the function for extract a feature for everything. Entropy, don't need to do it. It already exists. Kurtosis, skewness. So let's run this. And normalize the features, like normalize because we have better results with normalized values. So it means the standard deviation, the mean, and we're gonna do the normalization. And generate normalized features. So we generate our features. Let me see, training all features here. Okay, here the features, normalized features. So are the values. Now let's go to part 2, is the modeling. So we don't do the training and the test. Let's do the testing, okay? On this section, bring the load data. So you have the data here, but let's bring this data. It's very fast when you bring load data. And so now let's build the model. The model is going to be a sequence input layer. So now it's going to be the input data, Lstm with 100 hidden layers, dropout, Lstm, another Lstm, fully connected, softmax, and classification. Now we're going to define the hyperparameters. You see, have what is different here is in this learning drop factor. So it's going to factor in learn period, is the only thing. And do the training, we will not do the training because we didn't set. And the testing, and we test the setting, let's do the testing. So it's gonna run a little bit. So I'll show you the sound classification. So it's have very good result. Let's see the accuracy, 95% accuracy here. So you see the sound is very well classified of the compressor. And let's visualize the layers of the activations of the Lstm. So Lstm has like 100 by 100, but we're gonna see only the 40 of them. So these are the values within the Lstm. So some parts is activated, some parts is not activated. The part 3 is now very good for you to see. Let's open this run analysis. Let's open this as well. Okay, don't select this code generation, please. And here, what's going to be, the code is going to be generated. It's going to be exactly this, the function. This is not a live script, it's a normal script in Matlab. If you write this within the script, this is going to be, this means that it's allowed to generate code, okay? So don't forget about this. And so we're going to generate code of extract features. So we will extract the features and also from the raw data and string the classifier. So this we don't need to set because we already have some prediction values. We don't need to go through this. Let's see the report. So this report is very good for you to see how we can see the values of the C code, trace the C code in Matlab. So this is the streaming classifier. And for example, what is the function? It's called a streaming classifier. So here, if you write, this is the trace code. That's a very good tool. So what's showing is you write you have the C, the line of code in Matlab, and you can see the line of code in C and do the opposite. So you can trace every line of code in C to Matlab. See? This is very nice to see. I've never seen a tool doing this. So it's going to give you very good. For the struct features, you do this. So sometimes a very big part of Matlab code. Click twice, it's going to be a just if test. The opposite here. One line of code here can be many. You see here is a matrix multiplication. And you see how is in C, how crazy? You have a lot of values to set. Another one here. If you are good in C, good luck because chances to do something wrong is huge. And he's very good. This is what I want to show you. You can, I believe you don't have this in your license. You need to download the coders, okay? Just go to the add-ons. Sometimes the coders are not provided by the license, but you have license university, you have access to the coders, okay? Go ahead, download the coders and you can visualize this. And also you have some code inside. All the codes are here. See, I want to know let me see, there is no, let's trace off. So have some code here, another one here, okay? All C code. So thank you. Let me just finish the slides, give you 3 minutes more, I promise. Okay, now methods deep learning support. First of all, let me show you the 200 examples. Just say all the time. Here you have in your documentation, if you press there, you have a deep learning HDL or deep learning toolbox. How to deep learn with images, time series, tuning and visualizations, parallel in the cloud, applications, import, go to examples. You see a lot of examples of how to get started with all different kind of data, images, signal classifiers. Sometimes some of them are very advanced, and the state-of-the-art deep learning models for segmentation, for here segmentation. We have using image processing, using LiDAR processing. It's automatic driving. Look at this, and signal for processing. So go ahead and visit this reinforcement learning. 200 examples you have here. Okay, visit this page. And let me finish here. So Matlab is focused on towards engineering and science workflows. So Matlab covers the entire workflow where users can improve productivity by using these interactive apps that expedite analysis and also generate reusable code. The Matlab has models that can be deployed anywhere, embedded code or in the cloud. Also, you have interoperability with open source frameworks, TensorFlow, PyCharm, we imported one of them. Users have access to support from experienced methods, engineers, and development, training, and consulting. So this is this slide is going to send to you maximum tomorrow, okay? And you can access this deep learning on-ramp. This is a very good. If you want, you have to have a certification of this event. I encourage you to do the deep learning on ramp. Deep learning on ramp is going to give you, it's 2 hours on one tutorial, and you're going to have a certificate from MathWorks saying that you finished the deep learning on ramp. And also the video series, go there and visit. There is a deep learning ebook, machine learning ebook. Some of the information I presented are from there. It's very, very good information. And also for professors, you can go to teaching deep learning with Matlab. Thank you for attending. Please fill the feedback form. It's in the email. If you forget, go there, and we are trying to. We will try to send you another email for reminding you to do this. It's very important for us to give your comments for the next events. Stay tuned for comments events. This is the first one. We are very proud to talk to you guys. And please explore the resources and maximize the deep learning experience with Matlab. Thank you very much.
Thank you, Flavio. Thank you very much. So can CES and MathWorks folks unmute?
The chat information, we're gonna see the questions, and some questions that was not answered, so we're gonna send an email. Okay, thank you. Professor Dr. Ru, you want to talk? We finish here.
No, Flavio, are you addressing the questions right now? Is there any comments from CS or MathWorks team?
Hello, Dr. Roh, can you hear me?
Yes, I can hear you.
Yes, concerning the questions, I believe we answered most of them on the chat. I think there were a couple of specific questions that we will probably share the answers for by email to the people who asked, if that is okay with you.
That's perfect. Yeah. So I mean, that will be probably better that we can discuss among ourselves, and then we can communicate through emails. So if there are no pressing issues from our team, let me just remind you what Flavio already said. Please fill out the feedback form because we need justification for keep doing the next events. So your feedback forms are the justifications for follow-up sessions. So take some time. It's not going to take more than 5 minutes. Just fill out these forms. I have shared the links. If you do not have the link, yeah, Cecilia is sharing the link. You can come to our website and fill out the forms. And your emails are in our mailing list. We'll be sharing any information that comes up for regarding upcoming events. And I hope to see you guys soon. So I guess that's it from us. Thank you very much. And let's give a virtual hand to Flavio for his heroic effort. Thank you very much, Flavio. Bye-bye.
Thank you, Dr. Ru. Thank you.
Bye.
Thank you, all of you.